Welcome, everyone. Today, we are embarking on a strategic journey into the foundational concepts of generative AI. As business leaders and technologists, understanding the engine under the hood is critical. By the end of this session, you will clearly understand the critical differences between various AI models, specifically focusing on pre-trained and fine-tuned models, and how to apply them strategically to drive measurable business value. Let's get started. Let's begin by defining what generative AI actually is and how it differs from the AI we've used for the past decade. As noted in our first bullet point, traditional artificial intelligence was highly specialized. It required data scientists to build custom models from scratch to perform specific predictive tasks, like forecasting inventory or flagging fraudulent transactions. Generative AI represents a massive paradigm shift. Instead of just predicting numerical outcomes or classifying data, generative AI creates entirely new content, be it text, code, or images. Why is this so revolutionary? Because it democratizes AI. You no longer need to write complex Python code to extract value. You interact with these systems using natural language prompts. This fundamentally changes how organizations operate. We are moving away from traditional MLOps, where teams spend months training a single predictive model, into the era of LLMOps, where teams leverage incredibly powerful, existing models to orchestrate complex business workflows instantly. This shift is the foundation of modern AI strategy. Take a look at the diagram on your screen. On the top path, we see the traditional AI lifecycle. It requires custom-built architecture designed strictly to predict and classify, culminating in highly specific use cases like anomaly detection. Now, follow the bottom path representing generative AI. Notice the transition in the input method. It utilizes natural language instead of raw code. The output engine completely shifts to creation and generation, enabling broad applications like drafting documents, summarizing meetings, and translating languages. This visual perfectly encapsulates why generative AI is scaling so rapidly across enterprises. It removes the technical bottleneck of custom model creation and replaces it with intuitive, conversational interaction. Now that we understand the shift, let's look at the engine powering it, pre-trained models, frequently referred to as foundation models. What exactly are they? A pre-trained model is a massive neural network that has already been trained on a colossal corpus of internet-scale data. Through this extensive training phase, the model develops a deep, fundamental understanding of human language, grammar, reasoning, and even coding logic. Why is this important for your business? Because training a model of this magnitude from scratch requires tens of millions of dollars and specialized supercomputing infrastructure. It is highly impractical for most organizations. How do we solve this? Technology partners like Microsoft and OpenAI shoulder the burden of the initial training. They provide these pre-trained models to you as a service. You simply access them via an API or through embedded solutions like Microsoft 365 Copilot. As we dive deeper, recognize that these models come in various flavors: large language models, LLMs, like GPT-4 for text, code models for programming, and multimodal models capable of understanding images and audio simultaneously. Let's walk through the architecture shown here. At the very top, we start with internet-scale data, billions of parameters of text, books, and articles. This massive data lake is fed into a supercomputing infrastructure, which crunches the data over weeks or months. The output of this monumental effort is the central node you see highlighted, the pre-trained foundation model. This central hub is incredibly versatile. Depending on how it was architected during that training phase, it branches out into specific capabilities. It can become a large language model for text generation, a diffusion model for creating images, or a multimodal model that seamlessly blends text, audio, and visual processing. The beauty of this structure is that the hardest, most expensive work is already done before you even type your first prompt. So, why should an organization rely on pre-trained models? The primary answer is speed to value. Using a pre-trained model, as is, means you are leveraging its vast, built-in capabilities without spending time or money altering its underlying architecture. For the vast majority of business needs such as drafting marketing copy, summarizing complex email threads, or translating documents, a pre-trained model is exceptionally highly effective. Why is this the go-to strategy for enterprise adoption? Because it offers the absolute fastest time to value with minimal setup and highly predictable costs. How does your team access this? It's already embedded in the tools they use every day, like Microsoft 365 Copilot, or accessible for developers via Azure OpenAI services. However, there is a crucial deep dive concept you must understand. Pre-trained models are frozen in time. Their knowledge base is vast, but it stops on the exact day their training concluded. They do not automatically know your company's proprietary data, internal HR policies, or live inventory levels unless you explicitly provide that context. This simple but powerful flowchart illustrates the decision-making process for immediate AI adoption. We begin on the left with a defined business need. We then evaluate the task type. If the task falls into the general or common category, which accounts for a massive percentage of daily corporate workflows, the direct path leads us straight to utilizing a pre-trained model. From there, the outcomes branch into practical applications like drafting and summarizing, ultimately culminating in what every business leader wants to see: fast ROI and low cost. This visual reinforces that you do not need to over-engineer a solution when a powerful, out-of-the-box pre-trained model can resolve the business challenge instantly. While pre-trained models are incredible, they are not a silver bullet for every enterprise challenge. We must understand when and why they fall short. As noted, the core limitation is that off-the-shelf models are generic. They lack your company's proprietary jargon, they don't know your brand's unique voice, and they struggle to consistently output data in highly rigid, strict formatting schemas required by certain industries. Why does this happen? Because standard models operate on probabilistic guessing based on general internet data. They are designed to sound plausible, but they do not possess deep, specialized domain expertise. How does this manifest in reality? If you ask a standard model to draft a highly technical medical document or a complex legal contract, you will likely get a generic tone, formatting inconsistencies, or worse, hallucinations where the AI invents information. A deep dive distinction here is crucial. You can feed a pre-trained model your documents using a technique called RAG to improve factual accuracy, but RAG does not permanently change the model's inherent vocabulary, tone, or structural behavior. Look at the breakdown of limitations on your screen. Starting with the pre-trained model at the top, it runs into a wall of enterprise constraints. When forced to deal with proprietary jargon, the model defaults to a generic output. When faced with strict compliance formatting, it yields inconsistent structures. And when operating within a niche domain, the risk of hallucination or making things up spikes dramatically. All these failure points converge on a single, critical realization highlighted at the bottom: the need for customization. This diagram illustrates exactly why organizations eventually outgrow out-of-the-box solutions for their most complex, mission-critical workflows, necessitating a deeper level of AI intervention. When a pre-trained model is too generic, we turn to the ultimate solution: fine-tuning. What exactly is fine-tuning? It is the intricate process of taking a foundational, pre-trained model and subjecting it to a secondary phase of training using your organization's highly specialized, meticulously curated data. The basics of this process involve actually adjusting the mathematical weights and parameters inside the neural network. Why do we go through this effort and expense? To achieve a level of extreme precision that a general model simply cannot reach. Fine-tuning allows the AI to deeply internalize industry-specific terminology and effortlessly generate complex, strictly enforced output structures. How is it done? Your data scientists feed the model thousands of high-quality, domain-specific examples like a massive database of past legal contracts or specific medical diagnostics. The model studies these examples to learn the exact pattern and tone required. A critical deep dive distinction for business leaders: fine-tuning changes how the model behaves and speaks, internalizing your format. Conversely, RAG retrieval augmented generation changes what facts the model retrieves. They serve two different, but complementary, purposes. Let's visualize the mechanics of fine-tuning. On the left, we have two inputs feeding into the central process. First, we take our existing, powerful pre-trained model. Second, we introduce our curated domain data. This is your company's secret sauce, the specialized knowledge. These two elements merge in the fine-tuning process node. Through this computational training, the system outputs a brand new asset, a custom fine-tuned model. Notice the outcomes on the far right. This custom model now inherently possesses high precision and natively speaks with your exact brand tone and jargon. It no longer needs to be constantly reminded of how to format its answers. The formatting is permanently baked into its neural pathways. To make sound strategic decisions, we must look at a deep dive comparison of pre-trained versus fine-tuned models. Think of this as the classic buy versus build dilemma adapted for the AI era. As our basics outline, a pre-built, pre-trained model is incredibly fast to deploy, very cost-effective, but ultimately generic in its behavior. A fine-tuned model, conversely, offers unparalleled precision and is perfectly tailored to your enterprise, but it demands significant investments in time, curated data, and cloud computing budget. Why is this comparison so vital? Because aligning your model choice directly with your specific business goals prevents you from over-engineering simple problems, which can cause your cloud consumption costs to balloon unnecessarily. How do you choose? You must rigorously evaluate your workflows based on volume, complexity, and regulatory compliance. Our deep dive takeaway is this: leverage pre-built tools when you need immediate, predictable ROI on everyday tasks. Reserve your investments in custom, fine-tuned models for areas where specialized AI will provide long-term differentiation, protect unique intellectual property, and generate a distinct competitive advantage in your market. This diagram represents the ultimate executive decision tree for AI strategy. From the top model strategy node, the path splits into two distinct operational choices. The left path, pre-trained/pre-built, highlights the advantages of agility. You gain fast deployment and predictable cost, making it perfect for scaling general productivity. The right path, fine-tuned/custom, highlights the advantages of depth. It unlocks domain specificity and high-precision control. As a leader, your goal isn't to pick just one side of this chart, but to understand that a mature enterprise AI architecture will strategically utilize both sides, deploying pre-trained models for operational breadth and fine-tuned models for strategic depth. Let's ground these concepts in a powerful, real-world use case. Consider a large financial institution tasked with processing complex, multi-million-dollar loan agreements. If they attempt to use a standard, pre-trained model for this task, they will encounter friction. The basics of the problem are that generic models struggle to interpret the highly rigid formatting and incredibly unique legal clauses specific to commercial finance. Why is a standard model insufficient here? Because in finance, minor errors or hallucinations carry massive compliance, regulatory, and monetary risks. Generic AI simply isn't safe enough. How does the bank solve this? They take a foundational model and fine-tune it. They feed the neural network tens of thousands of past, legally verified loan agreements. The model learns to natively understand niche financial terminology, regulatory obligations, and exact formatting requirements. Our deep dive result shows the immense value of this approach. The bank now owns a highly efficient, custom-tuned model that processes complex contracts with staggering accuracy. This drastically lowers their compliance risk, slashes the hours spent on manual legal review, and creates a secure, repeatable, automated workflow. Follow the workflow of our financial use case in this diagram. It starts on the left with the raw material, thousands of verified loan docs. These are pushed through the fine-tuning process, resulting in the creation of a specialized custom finance model, acting as the brain of the operation. This new model has two critical capabilities shown branching to the right. It natively reads complex clauses and enforces strict formats without needing constant prompt engineering. Both of these high-precision capabilities funnel directly into the ultimate business outcome on the far right: reduced compliance risk. This visual demonstrates exactly how investing in fine-tuning translates raw data into a secure, risk-mitigated business asset. As we conclude, let's establish a definitive framework for choosing the right model strategy for your organization. What we are looking at is a triage system for AI adoption. The basics are simple. You must ruthlessly match the AI capability to the exact complexity of your business problem. Why? To maintain a delicate balance between driving rapid innovation, controlling cloud compute costs, and managing enterprise risk. How do you execute this? Here is your rule of thumb. First, use pre-built, off-the-shelf tools for general tasks like email and summarization. Second, if the AI needs to know your company's specific facts, policies, or live data, implement our Generative augmented generation to ground the pre-trained model in reality. Finally, reserve fine-tuning strictly for scenarios where the model must natively speak a highly specialized language or output in rigid, proprietary formats. The deep dive takeaway for every leader in the room is this: start simple. Prove business value and secure quick wins with pre-built tools and RAG. Only escalate to the cost and complexity of fine-tuning when the business case unequivocally demands specialized precision. Thank you. This final diagram is your strategic blueprint. At the top, every project begins when you assess the business need and evaluate the task requirement. Depending on the answer, you route your strategy into one of three buckets. If it's about general productivity, you route left to pre-built and pre-trained models for immediate impact. If the task requires accurate, factual enterprise data to prevent hallucinations, you route down the center to RAG integration. But if the project demands strict adherence to niche jargon and formats, you route to the right and invest in a fine-tuned model. Keep this visual in mind during your planning phases to ensure you are deploying the right level of AI sophistication for every unique challenge.